We're going to step through the first project together, since this is mostly just meant to review CS200 topics, and sometimes people are rusty on that, and it'll just be easier for us to go through it together, and I can explain step by step what's going on, than having to really struggle with all of the array stuff and file IO stuff. So, first thing, you'll want to have a photo editing program. I use Glimpse, and I also use Genie as a text editor. And inside of the student repository, under debugging and testing, CS200 review, images, there are different image files, and we can open these up both as a image in here or see the raw data. So part of this assignment is going to be loading in the image file. This is just plain text. We can load it in and parse it, and also to save it back out. So we'll have to talk about how this is structured as well. Now at the moment, when you first have the program set up and you haven't done any programming yet, it runs and there's a program here, but when you say load image, it's going to fail, I guess. Yes, because we haven't programmed that part in yet, and that's part of one of the things we need to do. And we're also going to be writing filters. So a lot of this you don't need to look at. This is all just a part of a already working program. Here's the image manip app, and it has all of just the program itself, the menus. When you first launch, it will tell you what the image path is and what it sees in that path. So by default, for this code blocks project, the project is in here, and it's going back in here for the image files. So that's where it will read and write the image files too. Okay, so when we run this, we hit enter, we would load an image first. It's not going to load an image because it isn't programmed in, but then from there the main menu would have loaded image of whatever we typed in, and then we can apply filters. There's 4 options. I have 1 already written. The rest are up to you. I might have 2 written. We'll see. And then 3 is to save it back out. So if we'll be starting off with image.cpp. The image.cpp file is just how we are storing the data. It has a dynamic 2D array of pixels, and each pixel has a red, green, and blue value. So this whole part here is a header of the file, but the rest of this is going to be red, green, blue, red, green, blue, in that order. So red, green, blue, this is 1 pixel, this is a 2nd pixel, this is the 3rd pixel, and so on. So we have a 2D array. You don't have to worry about allocating the memory here. I've done that for you. But here we're allocating the dynamic array of some size. We have image width and height. I believe these are hard-coded at 300 by 300. So all of these images are 300 by 300. And we'll need to first be able to load our image in. So again, it shows pixels, RGB values, but there's also a header to this file. There's P3 that specifies what the file type here is. It is a ppm file, and it's the P3 format. This is a comment. We can kind of ignore it or overwrite it, but we need to know that the 2nd line is a comment. Then on the 3rd line we have width and height of the image, and number 4 is the color depth. So for the most part, we can just store these somewhere or hard code them in, because we're not doing a really big sophisticated program. We're always going to have 300 by 300, 255 color depth, and then we're going to output a bunch of pixels. So as we're looking at this, we need to think about how we're going to load this in with a text file. We are including the fstream library. If you remember, that is to read and write files. So in here, we're going to try to load an image from the file name passed in. So we need an ifstream object. I usually name them something like input. And I can pass in file name, and this goes to the constructor to open that file. Alternatively, you could just have the declaration of this variable and say input.open file name, and that should be fine too. I like to also have an if input.fail. This will tell us if for some reason there is we aren't able to open the file. So now if I go ahead and run this and I type in a file that doesn't exist, it'll say failed to open file. So it's good to have error checks. Okay, so first we're going to think about the header, and then second we're going to think about all of the pixels. So the header, the first line is that P3. We don't necessarily need that in the image. We do have something to store the color depth. I have a const for the width and height, so we can kind of just ignore those values, and we can also just keep this hard-coded. So for now, I'm going to create a string buffer as a place to store information, and then we can throw it out, we could do something with it if we wanted to. And I need an int buffer. Maybe I'll put these up here. So first, we need this line. Get line will give us a whole line of text from whatever input stream. And I'm going to just put it in the str buffer. This is the P3 line. We can use getLine with cin as well, but we're not working with the keyboard input right now. We're working with our input file. Next we'll do getLine input string buffer again. This is the comment right below it. But we do not care. We can put our own comment or just leave it kind of like an empty comment. Then next we need to load in the width and height. So I'm going to use input and use the stream operator this time. So this will load the width and the height. They are separated by spaces. If you don't remember, when you do an input this way, or if we were using cin for example, this is what we use to input integers and floats, and we can input strings, but it will stop at the very first space. We can't enter strings this way that have a space in it, like if you were writing your full name out. And if we wanted to get a full line of text, we would use this format, and that only works for strings, because that would be like if we wanted to put our full name, or maybe like Overland space park, that would get the entire line of text ending at the new line. So it is the same with our input file streams. We have input and the input stream buffer, the input stream operator. We're going to throw it in the int buffer, but really we're just kind of going to throw these away because these are hard-coded anyway. We're going to keep them at 300, 300. Finally, we're going to load in the color depth here, and we have a variable for that. So that is in the m_color depth. So we're storing that. Okay, so that will load the header part, just this bunch. Next, we need to think about loading in the pixels. Now, since we're only working with 300 by 300 images, all of the images are going to be the same. We're going to have, I suppose, 300 by 300, 90,000 pixels. And each of these are going to have their own RGB values. So what we're going to need to do is iterate 90,000 times to get all of the RGB values. What we can do here is we can use a while statement to load 1 pixel at a time. And we need to think about how we're storing that. So in image.hpp, we have m_pixels, and we can access pixels just like a normal 2D array. And with a dot operator, we can say red is 255. These will all be going from 0 to 255. Same for green, same for blue. So we can assign values by using the array name, X and Y indices, and the red, green, blue. We're not going to hard code color values for each of these. We're going to be loading them from here, but how do we do that? Well, we can use while input is able to read in a value and then store it into, what are the XY values here? We'll talk about that in a moment. So this would load it in and store it somewhere. We don't know where here is yet, but we could have it load in red and green and blue all at once. And so every time it's here inside the while loop, it will have loaded the next set of pixels. So what I'm going to do is I'm going to create two counters, an X counter and a Y counter, to keep track of which pixel we're looking at. And inside of here is where we're going to add one to the X coordinate or add one to the Y coordinate as needed. So in here, what it's going to do is the way files load, well, at least from here, we're going to have 1, 2, 3, 4, 5, 6. It's going to load from left to right. And so also, let's look at comparing these. I'm going to set this to our 0 to 255. Here we have 51 as the red value, 46 as the green value, and 25 as the blue value. And we can go to the next one and the next one, so it will load each of these. So in here, we've loaded one pixel. We need to make sure that the next time we're loading by going through the while loop, we're going to load the next pixel over. So x plus plus, adding 1 to x. But if we kind of just went on forever without doing anything besides that, it would come over here to pixel number 299 in the X position and then keep going. But there's nothing over here. So we need to make sure that we loop back around once we hit the end here. So to loop back around, once our X value has hit the width, we're going to set X back to 0, kind of like a typewriter would work, I guess, and add 1 to the Y. So it's going to go all the way to the side, hits the edge, X is now 0, add 1 to Y. So what we're going to do is say if X is now greater than or equal to the image width, that's this constant int here I have, we're resetting X to 0, and we're going to add 1 to Y. And that should be good. We could also add some error checks, because what if for some reason this had too many pixels listed in it? If for some reason this image file were malformed, we want to make sure it doesn't add too many items into the array. If it goes outside of bounds of the array, it's going to crash. So this right here is just going to be just a error check. So if for some reason the Y ends up being greater than the image height, well, we can keep resetting it to the very last pixel or something like that. We could do that, or we could just say continue or some other sort of thing. I would say at this point, if for some reason this has gone out of bounds, we can do a break, which will leave the while loop and just kind of stop loading. If we have too many pixels, more pixels than we were expecting, then we just stop that. Okay. So at the end of here, we should have this be true. We've loaded the header and all the pixels, and everything should be good now. But how can you actually tell? Well, we can put a breakpoint here. In code blocks, I have to click on this to debug. In Visual Studio, the main big green play button is the debug. But I'm going to click on this, and I'm going to tell it to load bunny. Don't enter .ppm because it doesn't want that. And we can investigate what the values are. So this is when it's loaded all of the pixels, hopefully. Let's look at the m_pixels array. It has an array set up. Oh, it didn't like that. No, can I delete it? Pixel number 0, 51, 46, 25. Again, we have 51, 46, 25. So at least the first pixel has been loaded correctly. If the second pixel, or I think that's the 1, 0. 50, 45, 24. So if, a couple pixels have been loaded properly, we can pretty much assume that the rest of it's okay, unless something really weird happened. Where is my terminal? I can't find it now. We'll just close this and start it again. Oh, I accidentally overwrote that. So go ahead, load image, bunny. So it will say that it loaded. We don't have save written yet, so we can't really visually test this out, but we can look at the apply filter. So down here we have apply filter 1 and a filter 2, but then it's waiting for a filter 3 and 4. So that's something you'll just invent, kind of experiment around with different pixels. But let's look at what filter 1 does. We iterate through every pixel. We start at y0 up to the height of the image, x to 0 to the width of the image. We get a second x and y value, which is basically whatever the flipped item is. And then we replace whatever its RGB value is at this x and y coordinate with the other x and y coordinate we've found. So we will look at these filters again after we do the save. There's not really anything we can visually check, and it's a little hard to show in a text file full of 90,000 pixels. Okay, so for save, we basically need to do the opposite. We need to create an output file stream, OF stream, output. We can tell it to open the file name via the constructor, or we can just say output.load file name. I'm going to copy our error check right here. That makes it a little bit easier on us. We want to make sure we're not thinking that it's working properly even though it's not. So it'll just fail. It's easier for the load to fail than the save to fail, because there's what's wrong with just creating a file? It's easy. But if you're trying to load a file that's not there, that's harder to do. So what we're going to do is we're going to output the header, and then we're going to output the pixels. The header we can hard code. We can say output p3 end line. I can do a pound sign and say comment. We don't really need anything particular there. Let's output the image width and a space, then the image height, and finally the color depth. So that is this set of things. Now we need to output all of the pixels. We'll do for int y is 0, y is less than image height, y plus plus, and for int equals 0, x is less than image width, x plus plus, and we will basically just output. And again, they're on separate lines, so we'll just output the m pixels at position xy dot r with a new line. I'm going to just kind of organize it this way. And then we do a G and a B, and that's all. So this will output 3 pixels at a time, and 3 colors at a time, and that makes up 1 pixel. Then from here, we'll return true. How do we check that this worked? Well, stream output, output.load. It did not like something. Oh, it's open, not load. And I copy paste error. There we go. So we can load bunny. And if we save it as it is, it's going to just output back to bunny. If we can still load bunny, then that means we didn't mess it up too bad. So I can close that and open bunny again, and it's still okay. Let's also apply filter number 1. So that should show up here. Oh, I haven't saved it yet. Save. It automatically adds that 1 to the end of the file name, and you can see that it looks a little different. So let's go back here again. Again, we get a different X and Y value, and we kind of swap those. So what that ends up looking like is it takes whatever's the opposite edge and just moves it up here. And it does that for each of the pixels. We also have a filter 2. So I'm going to go ahead and just reload bunny. We're going to do filter 2 and save it. Oh, that didn't reset. That's a little bug I need to fix on my side. Anyway, so this one, it reverses the pixels. So it's not getting a different XY coordinate. It is storing the current RGB value of that pixel and then swapping them. It's setting the red to the green and the green to the blue and the blue to the red. So after that saves, then we can look at it here. So it has shifted those colors. Now for the other 2 filters, you can do whatever you want. I suggest messing around, kind of experimenting with different things. You can try shifting things. You could try doing a horizontal flip, like if we did this, or maybe a vertical flip like that, or a rotation. Those might be a little bit hard to wrap your head around. It'll be easier to think about color shifting. Like, how would you write a brightness filter? Or something to darken the pixels. How would you do that? So this isn't really so much, I'm not going to judge you on if your filter is amazing or, you know, does something really extravagant. This is more to just kind of practice and remember some C++ stuff, kind of figure out what you need to review. Also, I have some notes in here. So for instance, it will tell you if the file opens successfully, but if the file isn't being output correctly, you might need to go open it inside of a text editor. So I could open it in here and make sure this looks okay if it's for some reason not opening in Glimpse or your other photo editor. So for instance, let's say I forgot to output the color depth. That's going to affect it. That's actually kind of cool. Or let's say I just completely forgot to output the header. Can I still open this? No, it won't let me. So that's why you would need to use the text editor itself to kind of look at the file format and make sure it's in the correct format to be able to finish that up. Okay, so again, this is up to you. You can iterate through all of the pixels. You can set every third pixel to red. You can shift the RGB values. You can try to lighten them or darken them. Just as a note, the pixels go from 0 to 255 for each color, so they don't really go above that or below that, so make sure they don't do either of those. But otherwise, hopefully you'll come up with some cool stuff, and that's all for project 1. When you are ready to submit your changes, I'm not going to do it here, but you'll open your terminal, you'll do a git add dot to add everything that got changed, git commit with -m for a message, and type in something like project 1 done. And again, I'm not hitting enter, so I don't do it. And then you do git push to push it to the server. So those would be the steps to actually, for your source control, to get it updated. Then you take the URL from the website and then submit that in Canvas. So that's everything.